minus v over c square root. Okay, so how does this simplify? How does this simplify that? Okay, so square root. So together with 1 plus c over c. Okay. So here I have an object and the square root of an object. So this is the square root of 1 minus v over c. That's the square root of v over c. And so if I bring both of these things together under the square root sign, a minus b times a plus b is a squared minus b squared. So I get 1 minus b squared. Okay, so the ratio of the two times is this. So at the end of the day, our final result is, sorry. Okay, so our final result then is this. Just getting rid of the c, just to make it a bit simpler. In any situation like this, where you have, say, Alice, we consider her to be at rest, who we consider to be at rest, and Bob drifting with some velocity, v relative to Alice, what we have is Alice's clock looks something like this, tick, 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 time is ticking away like this. Bob's clock, relative to Alice's, in this picture, is ticking more slowly. So the picture looks something like that. Okay, and if we compare carefully, and if we look at this interval of time, delta t a, so when the time delta t a elapses for Alice, a certain time elapses for Bob. And we find that the amount of time elapsed for Bob, given that ratio there, is just the square root of 1 minus d squared over c squared. That's the time elapsed for Alice. Okay, so that's a general formula for time dilation. And if we were to stick in v over c equals 4/5, what is this thing? What is that square root? What is it? Okay, so this is square root of 1 minus 16 over 25. Is the square root of 9 over 25? It's 3 over 5. Okay, so let's see if this works. If we take 3 over 5, so in our previous picture we have this. What did we have? What do we have on here? 15? And 9 here, right? So let's see if that works. If I take 3/5 on delta t a is 15 here. What's 3/5 of 15? 9. Okay, that's 9, that's that 9 here. Okay, so time is not universal. Okay? Time depends upon the observer. So first I'll describe for you, to remind you sort of in physical terms what it is we have discovered, and then I'll show you that there's some very interesting geometry behind all of that. Okay, so here is Alice's space. So, and Alice is at rest in her space. And here's her clock ticking away, and here's her spatial axis. And she can see things happening in her space at various times according to her watch. Okay, so she can see various events happening. So an event is something that happens at some point in space at some time. So that's an event. So it will happen at this location in space at a certain time. And here's another event happening at this location in space at a different time. Okay, so let's suppose we just put those two events in Alice's space-time. So the first event was over here, and maybe it occurs at this time. So at this location, at this time, it's an event. Okay, and then a little bit to the right of that, a little bit later, another event. So if it's to the right, and a little bit later in time, it's another event. Okay, so for Alice, those two events happen at different locations in space. One of them is here, and one of them is there. Okay, so there's a spatial separation between them, and there's also a time separation between them. Okay? Now, if I have two events happening like that, like this and this, you can imagine that there is someone walking in Alice's space, drifting through her space at a constant velocity, such that those two events happen at the same location for that person. Okay, so this person is drifting at a speed such that when this event happens, he crosses that location, and he drifts across, and then this event happens, and he crosses that location. Okay, so from Bob's point of view, the first event happens right here, this microphone, and the second event happens right here, same location. Okay, so it's always possible then to find a Bob. If we've got two events like this, it's always possible to find a Bob that will connect those two events. Okay, so here is the Bob. The Bob is just this one here.